component along this is this.
Yes, sir.
Okay. So what is this? This is 3
3I
and
cap.
this is 4. It
Yes,
is
sir.
4. So this can be written as 3I cap plus 4j cap. Can we write it?
Yes, sir.
So in this way we have written here. Okay.
Okay, sir.
Good. Now I hope it is clear to all. Okay. Let's say this is the position vector r, and r can be written as r cos omega t I cap plus r sin omega t j cap. R sin omega t j cap. If there is any doubt, just tell me. Simply you can say me, just repeat, sir. It is very important. Don't confuse with it. Important and easy. Just it appears lengthier.
Clear, sir.
Good. Now, how can we find omega? As we know, omega is equal to dr upon dt. This is r upon dt. Can we write like this? Now see, if we differentiate it, we will get r, omega comes outside, and cos is differentiated into sine. Means it becomes a sine omega t.
So minus.
Just I'm keeping minus. Minus I cap remain as it is. Now r omega cos omega t j cap. Just tell me if there is any doubt. This is omega. Tell me whether it is clear or not. Is it clear?
Yes, sir.
Good. Now how can we find acceleration? Angular acceleration. In a similar method, just we are using alpha is equal to d omega upon dt. And this will be what? Minus r. Again we have to differentiate, means again omega comes outside. That is omega square now. And sine changes into cos omega t I cap. Now minus r omega square sine omega t j cap. We got a very beautiful result. See, what is this? Just compare it with the first equation, means position vector. If you get here the minus omega square common, inside the bracket you get r cos omega t I cap plus r sin omega t j cap. See, what is this? This is the position vector. The things which is in bracket, that is the position vector. So we have concluded that here alpha, we have calculated alpha. Alpha is equal to minus omega square r cap or r vector. But it is the linear velocity, and it is the acceleration and this is the dv upon dt. I have taken the linear, so it is not alpha. It is a linear. Is it clear? We are going to discuss the properties of this acceleration later, but first of all, you just understand what happened here. Tell me whether it is clear or not.
Yes, sir, clear.
Good. We got an acceleration. Means when an object is moving on the circular track, even with the uniform speed, there is an acceleration, and substantially the acceleration is this minus omega square r vector. What is the nature of this acceleration? Just try to understand. Popularly, this formula is also written as a is equal to minus v square upon r, because we have substituted omega is equal to v upon r. Omega equal to v upon r. If you substitute v upon r here, you will get v square upon r, and this is also a vector. Okay. Now, what does this say? Listen the things very carefully. Direction of A is reverse of the direction of R, because here we have got a negative sign. And what is the direction of R? Direction of R is this. This is the direction of R. Means if object is here, suppose the object is here at another location. Suppose the object is here. Then position vector at this location is this, away from the center. But here, if we mark the acceleration, it will be in this direction. This is the direction of acceleration. This is the position vector. In white, it is the position vector, and in red, it is the acceleration vector. This is position vector, and in red, this is an acceleration vector. Means this acceleration is towards the center of the circle on which the object is moving. So this acceleration is known as centripetal acceleration. Centripetal acceleration. Okay. And in physics, in the scientific terminology, this is known as radial acceleration. Radial acceleration. Why it is called radial? Because it is along the radius. Radial acceleration. So it is now fixed that whenever we are dealing with the circular motion, we got an acceleration towards the center, even the object is not changing its speed. I hope it is clear to all. I hope it is clear to all.
Yes, sir.
Good. Let's take an example. Suppose an object is moving. An object is moving on a circle of radius 20 centimeter with a speed of 10 meter per second. On a circle, object is moving with the 10 meter per second. Then what is the centripetal acceleration? As we know, A is equal to V square upon R. and V is given, that is 10, means 10 square, and R is 20 centimeter, means it is 0.2. So it will be 100 upon 2 by 10, and 10 comes over here. It is 500 meter per second square, and its direction is towards center. Okay, please copy the previous page and this page. I'm just giving you 20 seconds to copy all these things. It is a very important derivation. Don't take the screenshot. Okay. This is the uniform circular motion. Now we have the non-uniform circular motion. Non-uniform circular motion. See the things clearly. Again, just I'm taking a circle. Now object is moving on this circular track. See what is happening. Just I'm taking a velocity. Let's say velocity of the object is changing, that is 2t. Find the acceleration. Acceleration at t equal to 2 seconds. Now see what is happening here. Object is changing its magnitude also, and it is on the circular track. It means its direction is continuously changing. It's obvious. So direction is continuously changing and magnitude is also changing. It means it has two accelerations. First acceleration, A is equal to dv upon dt, and that is 2 meter per second. If we differentiate this, this will be 2. And one acceleration is v square upon r. Suppose its radius is 1 meter or 2 meter. The radius is 2 meter given. Then according to this formula, we can calculate the velocity at 2 is equal to 2 into t. It means it is 4 square and divided by 2. It means it is 8 meter per second square. This acceleration is due to change in direction. Due to change in direction. So this acceleration is called what? Radial acceleration. This acceleration is the radial acceleration. And here this acceleration is due to change in magnitude. So its direction is the direction of velocity. Listen the things very carefully. This acceleration is due to the change in magnitude of velocity. So this acceleration must